let's take a look at this last part of your linear law chapter. Okay, so basically now is where I have to do plotting of graphs. Okay, earlier they give you the coordinates, we manipulate the equations to solve for the unknowns. Okay, now is I need to plot a graph to solve for the unknowns. Okay, so first, this is the general order of step that you all follow. Okay, but again, let's just look through an example. Okay, to better understand how we do it. So in this question here, you are given two variables x and y. Okay, where they are related by this equation here. Then you are given a table of values. Okay, for their corresponding values of x and y. You are told by plotting a straight line graph of xy plus x against x squared. Okay, identify the abnormal reading and estimate its correct value. So first things first, you need to know. Okay, it's just like when I ask you plot a graph of y against x. Now your big Y is the xy plus x here. Okay, your big X is the x squared. So given the original equation that you have, okay, you need to manipulate it in the form such that on the left hand side you have xy plus x. On the right hand side you also got x squared. So obviously from this the first step will be to multiply x throughout. Okay, then that is how I can get xy and x squared. Now I just bring this x over, I will get xy plus x equals to ax squared plus b. So now I have my big Y, I also have my big X. Okay, where a is the coefficient of the big X. That's why we say a is the gradient, b is just a constant, so the y-intercept. So this is the first step, where you manipulate the equation, okay, to know what you are working with to solve for n. Okay, so now let's go into the plotting first. Okay, so this is a set of values for x and y. But now you need to be clear that your big Y and big X is completely different. It's not just x and y. Okay, so you need to construct a new table for big Y and big X. Okay, based off the set of values given to you. Okay, so how do I do that? Okay, very simple. Okay, let's take the first pair of values for example. Okay, when x equals to 1, y equals to 1. So my big X is x squared. Okay, so I'll just have 1 squared. That's how I get the 1 here. Same thing for big Y is xy plus x, right? So for the first pair of values again, okay, just calculate it out. You will have 1 times 1 plus 1. That's how I get 2. Same thing for the do the same thing for the remaining pair. So second pair again, just one more example. Okay, 2 squared. That's how I get 4. How I get this negative 1.04? Okay, put in the values given. So I have xy. So 2 times negative 1.52 plus 2. Okay, key this in the calculator, you will get this value here. And then repeat the same steps for all the set of values here. So if I got 7 pairs of values here, I should also have 7 pairs of values in my new big xy table. Okay, then now that you have this, okay, how do we start on the plotting? Okay, so always do what we call your graph planning. So first things first, I want you to identify the biggest x value and smallest x value. So obviously the smallest is 1, the biggest is 30.25. Okay, so let's determine the range of x values that I should use. Okay, because for linear law they won't give it to you. You have to determine on your own. So obviously we start from 0, right, for x, or big X here, sorry. Okay, my biggest value is 30.25. So let's use 32 instead of 31 because you always add an even number, it's easier to work with. Okay, next, for your big Y, your biggest value is 2, your smallest value is negative 27.28. So the closest even number that I can use for this, okay, is negative 28. Which means for your Y, or your big Y, I'm going to draw from negative 28. Okay, this one let's leave some buffer, 4. Okay, for your big X, I also can use some buffer. Let's use it as 34. Okay, if the space permits. So now, what do I mean by graph planning? Okay, so you just start the graph planning from the bottom of the graph paper. Okay, so you on your graph paper itself, okay, so do this in pencil because it's graph planning. Okay, always leave one big square space at the side. So let's say I start from 0 here. Okay, 2, 4, 6, 8, and all the way up to 32. Okay, then for your Y, again, I leave a space over here. That's why we start off negative 28 here. Okay, but I start off with negative 28 here. We slowly plot upwards up to the point where I get 0. That is when you draw your x-axis. Okay, this is what we mean by graph planning. So after you have done that for both your big Y and big X axis, okay, you will plot the points accordingly based on the pairs of values that you have here. Subsequently, okay, plot the values, connect the dots with a straight line. So the thing about linear law is the lines will never align all very nicely. Okay, that's why for linear law we always say we draw a, okay, at the bottom of the graph you'll see is the best fit line. So basically the line that passes through most of the points. Not necessary to be all, but it must be close to most of the points as well. Okay, so for example, if you take a look at the points that are plotted, okay, all these are the points that we have from the new big Y and big X values. Okay, so I just mark it out in red so it's easier for you all to see. Okay, so take your ruler. It should be very clear to you from the start that when you try and align the points with your ruler, no matter how you align it, this point will be off completely. And since already at the start you know there's an anomaly data, so that means this is the anomaly data, so when I try and adjust for your best fit line, I do not have to account for this point here. Okay, so if slowly try to align your points, okay, then okay, once you have determined that is the best line that you can draw to connect all the dots or most of the points, draw the straight line graph. Okay, and then make sure you extend up to the y-axis or your big y-axis. Okay, because you need your y-intercept subsequently. Okay, so that is the drawing portion after you plot your points. Okay, so part 1 they ask you identify the anomaly value and then give the correct corresponding value. So since I know this is the anomaly value, okay, the estimated correct value should be, okay, take a ruler, okay, please don't eyeball it. Okay, so take a ruler and then draw a dotted line. Okay, so all these workings have to be in your graph. Okay, so that's why the estimated correct corresponding value is negative 13. Okay, that's for the first part. For the second part, okay, from the graph, identify 2 points and use it to find the gradient. So why? Because I want to solve for A and B in the next part. Okay, because for part 2, they tell you from your graph, estimate the value of A and B. And we know A is the gradient, B is the y-intercept. So just calculate the gradient of this graph using any of the two pairs of values here. Okay, then y-intercept very straightforward. So, okay, just plug any 2 pairs. Okay, calculate gradient. Okay, so therefore A equals to -1 after I calculate my gradient. Okay, y-intercept even easier. Just look at the graph here. This is your y-intercept. Okay, so you just tell me y-intercept equals to 3. Therefore B equals to 3. That's all. So this is your A value, this is your B value. Okay. The next part, insert suitable straight line. So they tell you use your graph, find the approximate value of x. Okay, given this equation here. So the key concept for this is what? You need to replicate the original equation of the graph. Okay, so manipulate this equation. I need to form back the xy plus x, where y equals to something. So multiply the y over, I get xy equals to 0.4 minus x, bring the x over, I get xy plus x equals to 0.4. And this is my big Y. So I'm going to replace it with big Y equals to 0.4. So I need to draw this line of y equals to 0.4 on the graph that we drew earlier. So you will take a ruler again. Okay, find the value at 0.4. So this is the 0.4 value, which is the first unit. Okay, draw a dotted line of y equals to 0.4. Okay, and then find the corresponding value over here, which is 2.4. So from here, I can say that, okay, x squared equals to 2.4. So if I want to find the approximate value of x, just square root. And then remember when you square root, there's plus minus. So plus minus 1.55, 3SF, that's all. Okay, then for the very last part, again, it's not, although you write advanced, nothing too hard. Okay, I need to replicate the equation of a graph again. So from this original form, okay, manipulate it, so multiply the y over again. Bring the x term over. Okay, I get 4 minus 3x squared. Again, I have my big Y and my big X. So the equation that I need to draw is this straight line graph here. Okay, then whenever I draw straight line graph, I need a minimum of 3 points. So come up with 3 sets of values. Okay, and then draw the line to find the intersection, which is this line in blue here. After you have found the intersection, based off the coordinate, which is the solution, okay, then you do the solving. So at that point, I can say x squared equals to 0.5, which is what you have here, then solve for x. Okay, same thing. Now, I have my x value of this. Okay, sub in your big Y, which is this, to be equals to the big Y coordinate, and then do the solving, that's all. Okay, so all this has to do with the manipulation of an equation. Okay, so that's all for linear law. Okay, so make sure you are very comfortable, okay, and very proficient in manipulation. That's all there is to this chapter.